Hello and welcome back. In this example, we want to solve this differential equation using the separation of variables method. And it's also an initial value problem in which we want to find the interval of existence as well. So the first step in these problems is to always look at your independent and dependent variables and rewrite any derivatives using the dy dx notation. So let's do that first. We've got dy dx is equal to x times y plus 2. And now we need to separate our variables. And always, again, keep your differentials in the numerator and don't let them stay in the denominator. So first step is to multiply both sides by dx so that you have dy is equal to x times y plus 2 times dx. And then we'll go through and divide both sides by the y plus 2. And that will give us a nice separated form. Divided by y plus 2 equals x dx. And we can now integrate both sides of this. And in doing so, we're going to get the natural log of the absolute value of y plus 2 is equal to 1/2 x squared plus a constant c. And then the next thing for us to do is go in and exponentiate. And in doing so, we will have the absolute value of y plus 2 is equal to e to the 1/2 x squared plus c. And then using the rules of exponents, this will be e to the 1/2 x squared times e to the c, which we recognize is another arbitrary constant. Call it capital C again. And we also know that having the absolute value of the y plus 2 allows us to get rid of the absolute values because we have the arbitrary constant multiplied times the exponential. So that's going to be y plus 2 is c times e to the 1/2 x squared. And then if we subtract 2 from both sides and rename this y of x, we have y of x is equal to c times e to the 1/2 x squared minus 2. All right, next thing for us to do is to solve our initial value problem. Recall again that y of 0 was equal to -3. So in this case, y of 0 is c times e to the 1/2 times 0 squared minus 2, and that equals -3. So that's going to be c minus 2 equals -3. So c is going to be -1. So the solution of our initial value problem is y of x is negative e to the 1/2 x squared minus 2. And because we have a nice exponential function for our solution, the interval of existence is going to be all real numbers. So it's going to be from -infinity. And of course, the number x equals 0 is found in that interval. So recapping the problem, we first take our y prime and rewrite it as dy dx. We then algebraically separate the variables. We have all the y's on one side, all the x's on the other. We then integrate both sides and algebraically solve for y. And then at the end, if there's an initial value problem, we solve that and find the interval of existence.